Hello team, welcome to the learnviaelearn.com classes. So in today's class, I am going to take a very interesting, or I would say one of my favorite topic in data structures, and that is called as linked list. Alright, so there are so many topics I am going to cover in this linked list, and this video, or I would say this topic, will take at least two part, I would say, because I'm going to cover a lot of things in this topic, and I will give you some very good example along with their program. So this is going to be a very interesting session, I must say. All right. So what are the things I am going to cover in the linked list is, firstly we will cover from the very basic understanding about what is linked list. What is this linked list basically? And then we will see when we need to use linked list. What are the use case of the linked lists? And also we will I will give you some example of actual scenario where we need to use this linked list. Okay, what are the nodes in linked list? Okay, and what are the linked list operations? These are some very important points and a very pet question for the examiner and also exam point of view. And then we will see number of linked list, number of types of linked list, how many types of linked list are. Okay, and then we will compare the difference between the array and linked list, means when linked list are preferred over array, and what are the differences between links and linked list and array. Okay, these are two very important and interesting topics. So but before that I would say, if you don't have any or some doubt in array, so please go through my array video first, otherwise this will not going to be help you that much. And then I am going to cover the algorithm for all the types what I have mentioned here in linked list. Okay, and similarly for the algorithm I am going to cover the program implementation of all the all the types of linked list with the same algorithm what I have explained. Means I am going to implement the same program logic or the same story what I have told you in the algorithm. So these are some basic things, or I would say these are some points which I am going to explain in a very deep format, so that it will give you a very good understanding about complete in and out of linked list. Okay, so let's get started. Let me give you a very good example of a very simple example to understand the linked list by giving you example of a short story. For example, let's say everyone know about train. Okay, so I am going to explain some property of train and try to link those property or those specifications with actual linked list, or what we are going to see in our data structures. Okay, so what are the things, if I say a train, which comes in your mind? Number one, team, consider this is a train which carries some goods. Okay, for the sake of convenience for everyone, so this is not a train which who of a passenger. This is just carry trains who carry some goods. Okay, uh, so let's say I am having a train having of three bogies. Okay, now these three bogies is having some boxes. Oh, just a second. These bogies is having some boxes. Okay, let me fill it out. Suppose these are some boxes. Okay, let me just make it in this. And similarly, this box is also this bogie is also having some material in it. Just a second. Okay, similarly, this is my third bogie, which also contains some material. Okay, so these are the three properties of my bogies, which carries some object or some material into it. All right, now second thing we must notice whenever we saw a train that all the boxes are interconnected. So we must know where I need to connect this box. Obviously, the box where I need to connect this bogie. Obviously, I need to connect this bogie to next bogie, the very next bogie which comes to after first bogie. Let's say this is my first bogie. Let me mark it in black. This is my first bogie, this is my second bogie, and this is my third bogie. Alright, so we need to know where I need to connect this bogie. Similarly, I also need to know where I need to connect my second bogie. That is, I need to connect the bogie, I need to connect the second bogie to my third bogie. Okay, so two things which we need to consider here is, first, all the bogies is having some objects or some material, and we have a knowledge of next bogie where my previous bogie is going to connect. Means for bogie 1 we must know there is some bogie called as 2 where I need to connect this bogie. Okay, so these two things we need to consider here in my train example as of now. I will keep uh, uh, I will keep using this example in my future cases to give you the good understanding. Okay, now come to our data structure part. In data structures we have something called as a node. What we have here in our example called as a bogie, in data structures we used to call it as a node. Okay, so let me draw three nodes for you first, because I want to explain the same scenario. Okay, so this node is having two parts. Number one is called as a data part. Okay, so let me write it first. Before that, let me write uh, what are these nodes are actually. So I would say each element, let me change the color first. Okay, each element in the linked list is known as node. So if someone asks you what is node, then you can say that all the elements, I mean each element in the linked list is known as a node, and this node and each node is having two parts. One is called as a data part and another is called a link part. Team, as you saw in our train example, this node, or I say in this uh, bogie, we have some material. So here in our node, I'm saying that material as a some data. Okay, so we have two parts here for each node. Okay, so number one is called as a what? It's called as a data part. Let me, yeah, I really don't know why it's not. Come on. Okay, let me try to write it. Okay, saying data part. Okay, that's why. That's why I'm trying to, you know. Okay, let me make it like this. This is what this is called as a my data part. Okay, and this part and my this part is called as what? Is called as a link part. Okay, now come to a point where I have mentioned this, that we must know where I need to connect my link. So in data structure, link part must know the memory address of next node in the linked list. Okay, so let me write it, the exact definition or understanding what we have just learned about data part and link part. For data part, this part of every node of the linked list contains the information stored in that node of the list. Means this part contains the data of that particular node. Alright, now what is we have in link part? This part of the node contains what? The, oops, why is not writing? Let me make it large, like this. This part of the node contains the memory address means the location of the next node in the linked list. Okay, means we must know where this node is going to connect. Similarly, here we must know where my bogey is going to connect. In our case, my first bogey is going to connect to second bogey, and my second bogey is going to connect to third bogey. Okay, similarly, we must know where my this first node is going to connect. Okay, so suppose this is my link part, so this is going to connect to the memory address of my second node. Similarly, this part is also get connected to the memory address of my third node. Right, and let's say for an instance, my data in this node is, let's say, 22. This is suppose 31, and this is suppose 52. So this node contains 22, 31, 52, and these links are connected with each other with a link, and link is pointing to the memory address of the node. So team, these 3 points are very important. What is node, what is data part of the node, and what is the link part of the node. So please be careful and ask me through mail, or you can call me also in case you have any doubt in these three terms. Now let's take a look to what the actual definition we have in linked list. Okay, so we have gone through about what are the different elements and what are the things we need to see when we are talking about a linked list. Now come to the actual definition, what we generally used to write whenever it comes to linked list. So what is linked list? Let me write it here. uh, Font would be 11. Yeah, so uh, in computer sciences, a linked list is a data structure, okay, consisting of a group of nodes which together represent a sequence. Okay, so as we have seen, we have a group of nodes which contains some data and elements and are in a sequence. Okay, this is the same definition what we have understood as of now. Okay, now under the simplest form, if I am talking about the one of the simplest linked list, under the simplest form, each node is composed of two parts. Okay, one is called as a data part and second is called as a link part. I have explained you both part earlier in our example. Okay, now team, where this last node is going to point. Okay, my first node is pointing to my second one is pointing to the third one. So where my this third node is going to point? Team, the last node in the linked list is pointing to a terminator, which is used to signify the end of the linked list. Okay, so this node is signifying the termination of this link. Okay, so my last link is pointing to a termination link. Okay,